Section 8.2 is on the law of cosines, and this is a really helpful tool when dealing with triangles, because up until this point, all of our word problems with triangles had to have a right angle in them somewhere. And the law of cosines frees us from this. We can deal with an oblique triangle instead of a right triangle. So a triangle that doesn't have any right angles, we can't use SOHCAHTOA on it. We can use the law of cosines. So notation that your book uses, it uses lowercase Greek letters alpha, beta, and gamma for the three angles of the triangle. And then the sides opposite them, I have them kind of color-coded here. Across from angle alpha is always lowercase side length A. Across from angle beta is always lowercase side length B. Across from green gamma is lowercase side length C. All right, and here's our law of cosines. It looks a lot like the Pythagorean theorem with this extra little bit tacked on the end because the Pythagorean theorem only works for right triangles. All right, and textbooks tend to list this formula 3 times, but you don't really need this formula 3 times if you notice the pattern of the formula. So we start off with a squared equals b squared plus c squared. And then notice these two side lengths get repeated in the cosine bit at the end. And that's true no matter which way you rearrange the side lengths at the beginning. So if you have b squared over on the left, then you've got the other two being squared here, and they get repeated as coefficients of the cosine. Likewise, if I start off with c squared, I've got a squared plus b squared left over on the right, and those two side lengths get repeated in the cosine part of the term. And then whatever side length is by itself over here on the left, its partner angle ends up in the cosine over on the right. So A belongs to alpha, it shows up in the cosine. Likewise, if we start off with B over here on the left, its angle shows up in the cosine in the formula. If I start off with C squared on the left, then gamma shows up in the cosine on the right. All right, so let's practice this on an example. So we have a non-right triangle here with side lengths 8 inches, 12 inches, and 17 inches, and they want us to find the angle measures. All right, so it doesn't matter what we label these angles as. So if I decide that this is angle alpha, and I decide that this is angle beta, and that this is angle gamma, doesn't matter which ones I use where, but now that I've chosen those, the names for the side lengths are locked in. Alpha is always across from side length A, beta is always across from side length B, and gamma is always across from side length C. So we need to find all 3 of these angles, but let's say we want to start off with alpha. So remember, if alpha is going to be in the cosine on the right-hand side of my equation, I need to start off with a squared over on the left-hand side. So I'm going to write down my law of cosines here. A squared equals the other 2 side lengths squared minus 2bc. They show up again in the coefficients. Cosine of the angle across from A, which is alpha. And alpha is what we're looking for. So we're going to plug in A, B, and C into my formula. So A is equal to 8, B is equal to 17, C is equal to 12. Again, B and C get repeated, 17 and 12. And then of course I can't plug anything in for alpha because that's what we're solving for. All right, so let's be careful about this. I'm going to figure out some of these numbers. I got my calculator handy, so I don't need that for 8 squared, that's 64. 17 squared, maybe I do need a little help with. So that's 289 plus 144 for 12 squared. Let's see this coefficient with a negative sign, 2 times 17 times 12 gives me 408. All right, so just be careful when you're solving this equation. You can combine the 289 and the 144, but that 408 is attached to the cosine, so you can't lump that in with those 2 numbers. So I get 289 plus 144 and get 433. So I've got 64 equals 433 minus 408 cosine alpha. And we're just going to solve for cosine alpha. So let's subtract 433 from both sides. So I'm going to do 64 minus 433. I get negative 369. And then there's that negative 408 that's still attached to that cosine. Then I'm going to divide both sides by negative 408. So negative 369 divided by negative 408. And I get 0.9044. If I round it off, I'm going to keep that number in my calculator so that I don't lose any information. So 0.9044 is equal to cosine alpha. All right, so remember, we cannot divide by cosine to get rid of that cosine on the alpha. We need to use the inverse cosine button, and that will tell us what alpha is equal to. So alpha will be equal to the inverse cosine or the arc cosine of 0.9044. And I'm going to make sure I'm in degree mode here. I'm going to hit inverse cosine of my answer. My calculator has all the decimal places. I didn't round it off here. And I get 25.255. I'm going to round that off to 25.3. Okay, so we got alpha equals 25.3 degrees. All right, so they really want all three angles in the triangle. I'm gonna have to use the law of cosines again to find another one of the angles. All right, clean slate. Now let's see if we can solve for angle beta. It doesn't really matter which one you pick next. If I'm going to use angle beta in the cosine over on the right-hand side of the equation, I need to start my law of cosines with the b squared. So I'm gonna write down b squared equals the other two side lengths squared, a la the Pythagorean theorem. Law of cosine says we also need to subtract 2 times a and c. They get repeated. And then cosine of the angle across from b, which is angle beta. All right, this is going to be the same drill as last time. We're just going to plug everything in. B squared is going to be 17 squared. A squared is 8 squared plus c squared minus 2 times, repeat the a and c, 8 times 12, cosine beta. All right, 17 squared over on the left gives me 289 again. All right, remember that I can add together the 8 squared and the 12 squared, but not the stuff that's stuck to the cosine. So I'm going to have 64 plus 144 gives me 208. That's just these two numbers combined. And then we're going to do 2 times 8 times 12 for the coefficient of the cosine, which gives me 192. And then everything else is going to look very familiar. I'm going to subtract 208 from both sides. So 289 minus 208, I get 81. I got negative 192 cosine beta. Right? Then we're going to divide both sides by negative 192. So 81 divided by negative 192. And I get negative 0.421875. Again, you can just kind of keep the decimals in your calculator. You don't have to write them all down here like I did. And then we remember that we need to use the inverse cosine to solve for beta. Beta is equal to cosine inverse of this number. Of course, on my calculator, I just hit shift cosine, and then I call up that answer from the last thing I did, and I get 114.95. If I round off to one decimal place, I got to round that up to 115. So beta is equal to 115, and I can write that as my answer for beta. All right. And so far, so good. It looks like alpha is a reasonably sized angle, and so is beta. It looks like it's the obtuse angle, 115. So far, so good. You could use the law of cosines to solve for gamma, but there's a much easier way to do this. Now that we've got 2 of the 3 angles, you know that all 3 angles have to add up to 180 degrees. So I'm just going to use that fact for gamma. Gamma is going to be 180 degrees minus the 2 that I already know. So 180 minus 115 minus 25.3 gives me 39.7. And that's my third angle measure. All right, we'll save one more problem for the next video. It'll be a word problem.